This is the second in the series of videos covering the second lecture of the Computer Fundamentals topic of the IES Information Technology course. In this video, we look at the importance of each number system to the information technology industry. The decimal number system is found in every aspect of information technology because it's the number system used by nearly every culture. Granted, our numbers may look different because the symbols we use are different, but it all boils down to base 10 and place value as discussed in Lecture 1. One of the most common uses of decimals in the IT industry is an IP4 or Internet Protocol address. 4 numbers in the range 0 to 255, all separated by dots. But the decimal number system is far more important because it's where we as humans feel comfortable with numbers. Our brain is wired to think in terms of the decimal system. We're taught from an early age to count up to 10, to count by tens, and what all the places in our numbers mean. The 3 number systems all have a role to play, but as humans, we prefer our numbers decimal, and so we'll convert them accordingly to use them because this is how our brains think. By contrast, the binary number system is the computer's preferred number system. All processing and storing of data is done in binary. Computers know nothing but zeros and ones, on and off. It is important for information technology professionals and users to know that this is the case and therefore understand how the computer functions and stores data. Again, the 3 systems all have a role to play, but the computers we use only handle binary, and so we may enter decimal values or hexadecimal codes, but the computer will store them, after processing them, as binary. When storing data, a computer can store binary data only. Numeric data must be converted into its binary equivalent. How this is done is dependent on the type of number and the accuracy required. When storing text, the computer stores a code for each symbol typed in. There are many codings, but this video will consider the most general of these, Unicode, later. Data can also be color codes, which is briefly discussed at the end of the video, and in more detail in the image manipulation topic, but it can just as readily be sound, video, or other data. Instructions executed by the computer are given binary codes that we must either enter directly or have a program create for us. The first programming language is known as machine code, and it's a series of binary instructions and binary data. Now we use compilers to create this sort of code from more human-like languages. Locations in memory, whether in RAM or in some form of storage device, are also stored as binary values. So if it's all binary, why do we even consider hexadecimal? It helps us mere humans to make the cumbersome strings of zeros and ones of binary into a more manageable and easy to understand series of digits. A byte, 8 bits, is only 2 hexadecimal digits. So for example, A9 is the same as 101010001. 2 examples of where hexadecimal is commonly used is in the 3-byte color codes we use in image manipulation and web coding, and also in the codes given to written characters in the all-encompassing Unicode. Let's consider both these examples a little further, starting with Unicode. Before Unicode, there were a number of different coding systems. The most common was called ASCII, the American Standard Code for Information Interchange, but this quickly proved to be too narrow for international use and even too narrow for European use. Some of the coding systems conflicted with one another, and so the code for the letter A in one system might not be the letter A in another. It became necessary for computers to support many different encodings. But then Unicode provides a unique number for every character, and more are being added all the time. Now it's your turn. Try answering these Unicode character questions. You might want to open up the website unicode.org. A link appears here and in the description below. Pause the video as you do them. The answers will be displayed one by one. Try again and ask if you're still struggling. The RGB red, green, blue colouring system uses 6 hexadecimal digits, and it's discussed more fully in the image manipulation topic. Essentially it uses 3 bytes, one for each colour, written as 2 hexadecimal digits to give in excess of 16 million different colours. We will use it in the web coding topic when we set background, border and text colours, and in the image manipulation topic where we use the GIMP. Now it's your turn again. Try answering these RGB questions. You might want to open up the website color-hex.com. A link appears here and in the description. Pause the video as you do them. The answers will be displayed one by one. Try again and ask if you're still struggling. And that's the end of the series of videos for Computer Fundamentals, Lecture 2.